Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Cliosoft with Jeff Markham, who's going to talk today about IP traceability. So, Jeff, IP traceability has become much more of a problem as we start getting into things like automotive and aerospace, right?
Yes, I think you've seen recently with airplanes and such that if a defect emerges within a particular part of a system, like an aircraft or an automotive design, that the ramifications are extreme, and you have what they call functional safety issues that come in about trying to mitigate the problems that can arise. So knowing exactly what's on your chip and how it's used is extremely important.
You really want to know who to point to if something goes wrong, where to find the problem as well, right?
Yes, and also if you have a problem that you discover after you've already created your IP, you need to be able to notify the people who are using it that you found it, and they can make an ascertain whether or not it's critical to them or not.
So why don't you draw this out for us?
Sure.
So, Jeff, what are we looking at here?
So it's really that IP, particularly more complex IP, is really made up of a lot of different pieces, and you need to know what IP you're using and what it in turn uses. So for an example, it may be like a processor. So you may have a processor ALU, and then how many cores it actually uses, and then the cache size that it uses, and it may have different bus controllers. Some of these may be options that you can choose. And so knowing when you use your IP, how many cores you've got, pipeline depth, cache depth, as well as the particular bus controllers and other configurations that you can set are important because it can change the way the IP behaves, and it can either expose or hide kinds of defects that you have within that IP. So that's really why it's important to know what you're using, what it in turn uses. And then if your IP is reused in something else, it's really important to know who's using you, because if some issue comes up in the future, you need to be able to communicate that. So tools like ours, Design Hub, have this sort of bill of materials built into it. And also we have linkages into issue trackers like Jira and Bugzilla, so that when an issue comes up, you can very quickly go, oh gosh, this affects these people, and I need to communicate that to them. So that's why IP reuse is important. If you're using a process like ISO 26262, you're mandated to do that. Not only do you have to get that information, you have to report it. So getting the reporting capability is increasingly important.
And you brought up ISO 26262. One of the changes that's gone on in the marketplace right now is as chips are being used in more safety critical type of applications, yes. Right? So you do need to understand, for a liability standpoint as well as for reliability, what's the problem, where did it come from, and what else is here.
Yes, and if you're selling that system to somebody else, you have to report your functional safety conformance as part of your deliverables of that IP to them, or your chip or whatever. So it's very much a rigor that you have to do, and it's for some people new to the industry.
So where do problems typically crop up?
Usually in detailed validation. Most of the time the design teams are pretty good about finding defects, but when you actually put the thing into a system, you'll find unanticipated usages, or some of the constraints that you assumed at the beginning aren't true when you actually put it into the system. And so you may find that your tests are not quite adequate, or that you haven't really fully accounted for a situation that gets into the field. So usually it's unanticipated things of usage.
So defects show up at all times. There's no way you can keep all defects out. That's just too complicated. How do you make sure that you know where they are, where they came from, and that you have identified them?
It's usually by tying into some issue tracking system like Jira or others, where everybody in the ecosystem can report the defects that are happening at their level. And so if they find something in testing or in manufacturing, that they can inject the defects into the system, and that through tools like ours, Design Hub, you can hook up to those issue trackers and know when they happen, and then take appropriate response when they show up.
Tagging is another piece of this. How does that fit into here?
So there are various tagging standards that are emerging. Some of them are at the RTL level or in timing libraries, where you can sort of put information into that says, here's what's in it. But the more mature one is what's called VKIP tagging. It's usually at the artwork level, at the GDS2 stream level, where you can put information within the stream file itself that contains the information of what is in that particular tape out in terms of IP usage. Not only what it uses, but what it in turn uses. So it's a full hierarchical accounting of what's in that, including options like how many cores, how many caches. And that's important because you may be surprised sometimes that an IP that you're using, you didn't realize it was using something else that you're not licensed for. So that's a problem. You don't want to, actually make silicon with that kind of issue. And then there's also things like you may actually have different assets that come from Synopsys or Cadence, whoever the IP provider is, that depending on the options that you choose, you may need different assets, and it's good to account for all that. So VKIP tagging really allows you to snapshot everything that's in your design at the mask shop, and you can have people like TSMC or Samsung or whoever your foundry is, they can run a report and send it to you and say, here's what we think it contains, and you can make sure that it does.
One of the issues that comes up is with IP is security as well, particularly in terms of not so much what's in there, but what you don't want to be in there. So
Right.
What can it do and what shouldn't it do?
So if you have something like an ITAR block that shouldn't be shipped to a particular area, and so you make something specific for a particular geographic region, you can look for the presence of these secure IPs within your tape out and say, whoa, that shouldn't be there. And you can stop it before you actually make masks.
Let's drill into what a bill of materials actually looks like for IP.
It's basically a full accounting of what's inside of a block or an IP that you're using. Let's say I'm using an ARM processor. I may be using 3 or 4 of them, and I may be using slightly different characterizations or different options for them. And so I need to know I'm using Cortex A74 3 times, and I'm using these 5 or 6 different options, so that you get a full accounting of that. If I in turn use that processor in another piece of IP, then I'm using, they use me, and in turn I'm using the ARM processor, et cetera, down this tree. So it's very much a tree, and it's not only how many and what kind, but also what options you have, and that's the full bill of materials that you need.
And does that tree constantly change as you start introducing new versions and updates to the IP?
It does change. I mean, you may decide, some people swap out entire IPs. They're like, I found something better between Rev 1 and Rev 2, so I'll swap out. So the bill of materials does change. I may have thought I needed to use an option. I no longer need to do that, so I'll take the option out. So it does change from revision to revision, and knowing specifically what versions you're using within that bill of materials is also very important.
As you change out the IP, that also has an effect in terms of other things that are in that chip too, right? So now you have to go back and revalidate everything that it works with everything else.
You do, and that's part of the thing of having a bill of materials and knowing, particularly when you get into functional safety, if I swap out that IP, all of the validation that I did to make sure that my functional requirements are indeed met has to be redone. So you have to make sure that, when you swap it out, what tests are affected and what specifications are now invalidated because I swapped out that IP.
Is any of this IP rated like what you would do on, say, Amazon when you're buying something in terms of power, security, things like that?
There aren't industry-wide standards right now for validating or characterizing IP to that level. I think that's something that will definitely emerge in the future as things like functional safety take root in the market.
So along with this bill of materials, there's also a history type of reports that come into this too, like how often you've used this, what sort of problems you've run into in the past too, right?
Yes, I think the reporting capabilities are important because as you tape out more and more, you get more information, and your accuracy in terms of how you qualified and quantified your IP get better and better the longer it's out in the marketplace. And so being able to report on that and being able to make sure you thought the power was going to be this, but in fact after you've taped it out and had it out in the market so long, you find out that it's different, and you go back and update your information. So being able to report continuously, and particularly if you wind up getting audited, because if you're doing ISO 26262, you get audited, and so you need to produce these reports to give to them and say, they're going to ask that question, how many tape outs does this have? Boom, I can tell you today.
Does that kind of reporting always work consistently, though? Because you think about a lot of the chips that are coming out in the marketplace, a lot of them are very customized over what they used to be in the past, where you build one and it's good for 1 billion units.
You have revisions that you ship out, and usually when you do a mask tape out, it's of that revision, and so you need to keep track of the revisions, and then you'll know how many, they call these COTS systems that the mask shop will tell you, I made 50,000 of them, and so you can keep track of that over time. That's part of what reporting does.
Jeff Markham, thanks for a great explanation.
You're welcome.